Steel is used to manufacture a wide range of products, from tiny surgical tools to huge ships. However, it can become corroded or contaminated when liquid comes into contact with it. A new method to coat steel with the compound tungsten oxide has been reported by researchers from Harvard University in Nature Communications this week. It enables liquid to slip off the surface while keeping the steel strong. Dr. Ben DeLorme, a materials chemist from the University of Birmingham, explains to Rosalind Davis why this is so important.
Steel, whilst it being very strong, it's also susceptible to being broken down. If you scratch an old car, you get a lot of rust. And this is a problem for the car because you lose your strength in the material. Another problem is that things like to stick to it. When you're going in for an operation, the surgeon will use a steel scalpel. You don't want anything to stick to this scalpel, like bacteria, for example, which is why it'd be really attractive to create a scalpel where nothing sticks to it.
So what we really want to make here is slippery steel.
Basically, yes.
And these researchers in Harvard, they've developed a coating. What is in the coating?
The coating is made up of two layers. Tungsten oxide layer, which attaches to the steel, and then you have lubricant, which attaches to the tungsten oxide. Normally, this is done in a really smooth, flat layer. The problem with ceramic layers is that they don't like to bend very much, and then they break. If the metal bends, the tungsten oxide layer above will crack.
And that's your protective layer gone?
Exactly. So that creates a crack, and then anything you don't want to stick can get into that crack and stick.
So the researchers have now solved this problem?
Yeah, very interestingly, they've developed a material which has lots of cracks. I know, sounds completely counterintuitive, doesn't it?
So if you've created these cracks already, then why don't you get damage to the steel directly?
The cracks hold the lubricant, but they also allow that layer to move.
So how did they create these cracks? Did they make the material as usual and then sort of bash it up a bit?
So what they do is they took their steel plate and they submerged it in a vat of liquid. And in that liquid, you had your tungsten oxide particles. They're attracted to the metal when you apply a voltage to it. They find little sites and they stick there. And then eventually they start growing and growing and growing.
So what stops the steel in between the islands becoming corroded?
So this is where the lubricant becomes very important. The crucial thing is that the cracks are formed before the lubricant layer is applied, so that the cracks can then hold the lubricant. And it's the lubricant which stops things sticking to the metal. The tungsten oxide bonds directly to the steel, which acts as an anchor to hold the lubricant. That means that the lubricant doesn't wash off and go into the environment.
How did they test the material?
What they did was they used Scotch tape. So effectively you put Scotch tape on the surface and pull it off and see if the layers come apart.
So they tried to wax the lubricant off the steel and see whether it would stay stuck?
Effectively, yeah.
So these islands of tungsten oxide were strong enough that they stuck the lubricant to the layer even after waxing?
Precisely.
Have they tried this in real applications?
They have. They applied this coating to a surgeon's scalpel. What they found was the amount of E. coli that stuck to the surface of this treated steel was reduced. What they also found was that if they used a scalpel covered with this coating, it gave a much cleaner cut.
Ben DeLorme from the University of Birmingham, commenting on research carried out by Harvard University researchers, published this week in Nature Communications.